Once again, Professor Raymond Buck, my engineering notes again. And boy, this is thermodynamics, heat of fusion. And this is how my wife, Donna, she checked all the educational programs. So she's a teacher, and I gave her the project, and she had the whole project for the checking all my work for the educational tutor, and she came up with this educational tutor matrix. I've never seen nothing like it. Her design, and it just basically, she went through every function over several month period, and she just did an excellent job. She did an excellent job with the conversion factor handbook index. I mean, just a wonderful, wonderful person. And my first wife, Tanya, she was Mrs. Trebco, and she really, really would come up with ideas and concepts, and she knew the software inside out, just like my wife knows it inside out. But of course, I'm the inventor. Hopefully I don't have to keep doing this, making videos. But we have all my notes, and I get tremendous amounts of videos and notes, and we'll get all those captured. That's when I was doing the mass moment of inertia, and then you would do the calculations for all the different mechanical properties. And you get the bulk modulus and the modulus of elasticity, and the relationship between the bulk modulus, the Poisson's ratio, and modulus of elasticity, and of course G, which is the shear modulus of elasticity. You need all of that, especially when you're doing aerospace applications and you're looking at the mechanics of aerospace or aerial structures. Of course, the first law of thermodynamics, you do it by hand, and you look at the kinetic and potential energy and internal energy and the heat and work, and so you do all the calculations. And of course, I did a lot of matrix analysis. AC circuits, I was trying to figure out Kirchhoff's current law, Kirchhoff's current law, Kirchhoff's voltage law, thermodynamic relations for turbines and compressors and pumps. The work for, and of course, convergent and divergent nozzles, condensers, heat exchangers, all these components were necessary when you're doing power plant calculations. You start in the boilers, of course. And so this is how I started putting the icons together. Once again, I get the equations backwards, but I think we can see they're the work equations, and of course that's a Rankine cycle. All the different relations, adiabatic, isentropic, all the beam deflections, do all of them by hand. First law of thermal relations that for all the different pressure, temperature, and the partial derivatives that were required for the advanced thermodynamics, applied thermodynamics, Molecular diagrams, understanding the relationship underneath the curve. In different curves, this is temperature and enthalpy, and pressure and enthalpy, and of course you have your specific volumes, internal energy, enthalpy and entropy, your isentropic and Delphic relationships, quality formulas for steam, trigonometry calculations. That's old. I think that's from 1977, 1975, when I was trying to understand calculations. This is a curl. I was doing advanced calculus when I was in 6th and 7th grade. These are the menus, once again, of how I started coming up with the icon interface and how I wanted it to look like. And of course it looks just like what everybody else started copying, and it is, because these are my original note cards, sheets of paper, napkins, because I didn't always have a notebook. Mom and Dad would get you the notebook, but I was writing down so much stuff that they said you gotta cut some grass or get the notebook yourself, because I was writing too much stuff. That's when I had a chemistry set, and so I would always be in my room, always in my room. Now I wasn't antisocial, but I would go in my room and I would start doing different things. I made my own computer, took my radio apart, did the explosive assembly, put everything on a rug in my room, and then put everything back. My mom would think I was crazy. She's like, why did you take that radio apart? I said, I wanted to see if there was a person inside the radio. That's when I was 3. And of course, she was not happy about that. She said, I'm going to tell your dad. So I put it back in reverse order. So I was always going to be an engineer. These are the menus, and trying to figure out how I was going to. So I knew I needed a menu interface. I knew I had programs that I was working on, and I knew I had to do the conversion factors, to do the calculations. And of course, that's what I started to do. So a lot of people were playing games and things like that. The kids that were in my neighborhood, they saw I came up with a baseball stadium, and this baseball stadium, basically, it was a collapsible stadium. And when I would open it up, I had a baseball league. I called it the Finger Baseball League, and everybody would play in the Finger Baseball League. Al, Howie, all the people in my neighborhood, they know what I'm talking about because they saw it. And we all played using my league that I came up with. I was the leader of the Chicago Penguins. That was my baseball team. And fictitious characters, and had a very vivid imagination. So when I was talking about stuff like that, they didn't know what I was talking about. They didn't know how I came up with the baseball stadium. Everybody wanted to play with it. Brothers, nephews, people down the street. So everybody said, boy, those Bucks are genius, especially that Raymond Buck. He's a genius. But that's who I was. I'm a Cherokee Indian, and African American, and Scottish, Irish, of course, German. We would have our white relatives come to see us, and people were shocked. How can you be an Indian and have white relatives? Well, we had white relatives. And I'm Professor Raymond Buck, the inventor of the tablet computer. Touchscreen interface menu for the smartphones. I came up with the touchscreen interface that everybody's using, 5 or 6 billion people. I'm Professor Raymond Buck. I went to the Illinois Institute of Technology. I have a mechanical engineering degree, and I have an MBA from Capital University.